Algebra 2 Cram, New York State Algebra 2 Regents, Common Core, Solve Exponential Function Basics. Concept number 8, Different Bases. Be sure to order the complete Algebra 2 Cram session by inboxing me at memedicine@gmail.com. Exponential logarithmic equation. Solve the following exponential equation. 5 raised to the 2x minus 1 is equivalent to 7 raised to the x plus 4. Definitely press pause if you need to, and I'll give you a moment to think. All right, so hopefully by now you were able to press pause and arrive at an answer, and if you didn't, that's completely fine. Let's do this together. So this is the general format for an exponential function, where b is the base, and it's a constant. It has to be positive, and it can't be equivalent to 1, because if it were equivalent to 1, then you would have a constant function. Yeah, so if the base were equivalent to 1, you would get a constant function, because we know that 1 raised to any exponent is going to yield 1. All right, and so again, b is the base, or a constant, a numeral value, and x is the independent variable, but it's also the exponent, okay? Now, some people confuse this concept with a polynomial functions, but polynomial functions have things in reverse, where the base is the independent variable and the exponent is something like 2, 3, or 4. It's a constant. This is not the case, so don't confuse that, all right? Okay, so yeah, what we have to now realize is that the answer to an exponential equation is called a power. And oftentimes this is interchanged with the term exponent, but it's a misnomer. The power is the result of an exponential equation, okay? But what we have to do here in order to evaluate 5 raised to the 2x minus 1 is equivalent to 7 to the x plus 4 is we have to use a technique that can accommodate having different bases on the opposite sides of the equal sign. The base on the left-hand side of the equation is going to be 5, and 7 on the right-hand side, okay? So the technique we can use to solve this riddle is to take the common logarithm of both sides, and the common logarithm has a base that's 10, okay? And you're probably wondering, like, okay, what the heck is a logarithmic function? Well, a logarithmic function is the inverse of the corresponding exponential function with the same base value. But that's a lot of talk, so let me just show you what I mean by that. If we put y equivalent to the log base b of x, this is the same thing as x equals b raised to the y. So we basically have the inverse of our original exponential equation, okay? And remember that algebraically, in order to yield the inverse function of your starting function, all you're going to do is switch the independent and dependent variables, or you simply switch your x and y values. That's how you get the inverse of any equation or function algebraically. So for this particular inverse function, the constant, which is the base, is going to remain a constant. But the power, or the result, is going to now become the exponent that was in like our prior function. So yeah, the independent variable x now becomes the power or the result of this equation, and our exponent is now y, okay? So the way you would look at this is that you would say that y is the exponent that you raise base b to get our power of x. And since I previously indicated to you we're taking the common logarithm, the base is going to be 10. This concept is really like out there, but just learn the language, even if it feels a little uncomfortable in your mind. It's okay. It's just a different way of looking at something algebraically. I don't know who came up with this logarithm. I'm not even sure if I'm pronouncing it correctly, logarithmic concept, but it works. It comes in handy when trying to solve an exponential equation with two different bases on opposite sides of the equal sign, okay? So again, this particular exponential equation has different bases on each side. That's why it makes solving it a little bit more complicated. So what we are now going to do is take the common logarithm of each side and solve. And again, for the common logarithm, notice we're not writing any particular base b. And that's because the default value in your calculator for the common logarithm is going to be 10. So 10 is the base value being applied. But if the base were e, the natural number, then we would take the ln. This would be ln instead of log. It would be the natural logarithm, but that's not the case here, okay? All right, and so from the law of exponents, we can rewrite this entire statement as such. 2x minus 1 times the log of 5 is equivalent to x plus 4 times the log of 7. And that's because the exponent can be brought down and it multiplies the logarithm. Again, this is one of the laws of exponents, okay, when simplifying logarithmic equations. And although it might not be apparent right now, the easiest route to take here is to expand and simplify by applying the distributive property to both sides of the equation. So we distribute log 5 and log 7 on the left-hand side and right-hand side of the equation. And we're going to get 2x times the log of 5 minus the log of 5 is equivalent to x times the log of 7 plus 4 the log of 7, okay? Now what we're going to do is bring terms with x's and constants together. We're going to separate them. So once we sort things out, we get that 2x, the log of 5, minus x log of 7. We subtracted x log of 7 from the left-hand side, and we added is equivalent to 4 log of 7 plus log of 5. We added the log of 5 to the right-hand side of the equation, okay? And it canceled out on the left-hand side. So that's how we arrived at this step. And what we can do now is on the left-hand side, we factor out x so that we can get closer to figuring out what our x variable is equivalent to so that we can end up solving this bad boy, okay? So when we factor out x on the left-hand side, we get that x times 2 the log of 5 minus the log of 7 is equivalent to 4 the log of 7 plus the log of 5. Now we can determine what x is equivalent to by dividing by 2 the log of 5 minus the log of 7 on both sides of the equation. And we get that x is equivalent to 4 the log of 7 plus the log of 5 divided by the 2 the log of 5 minus the log of 7. Now what you're going to do is input this into your calculator. Make sure you know that you place the numerator in parentheses before entering your division command to keep things neat so that you don't get the wrong answer. And after inputting this in your calculator, you should get that x is approximately 7.379. After rounding, I think you'll get 7.37888, okay? And you can also check this. If you were to put this value in for x, both the left-hand side and the right-hand side of this exponential equation should be equivalent to each other, okay? So yeah, this is the solution or the x value, and it definitely is going to check. All right, so thanks for tuning in. And as you can see, intellectual comprehension of this material was not difficult at all. And after the short amount of time it takes for you to complete the entire Cram session, you'll be able to answer a battery of questions about any Algebra 2 concept. So tell your friends, colleagues, classmates, whoever's taking this course with you, and yourself as well, to inbox me at memedicine@gmail.com to order and purchase this complete Algebra 2 Cram session. Good luck studying.